A custom fan project does not begin with "which fan do you sell?" It begins with the equipment, the required operating point, available space, electrical supply, control system, environment, and evidence needed for approval. The Longwell sample imagery here demonstrates real fan geometry only. It is not presented as a complete development record for the sample shown. Before concepts are compared, the team needs one controlled requirement snapshot. Define airflow and pressure at the relevant air condition, the installation envelope, inlet and outlet restrictions, supply and control interface, acoustic target if applicable, temperature and contamination exposure, compliance scope, and acceptance evidence. Unknowns stay visible as open items. Quietly assuming them creates expensive rework later. Several architectures may satisfy the same headline duty. Compare fan type, impeller and motor pairing, control approach, packaging, service risk, tooling, cost, and technical uncertainty. The highest predicted efficiency is not automatically the best system solution if it cannot fit, communicate, stay within motor limits, or be produced repeatably. A concept review documents why one route advances. The digital fan is placed inside the customer's actual equipment envelope. Check mounting datums, inlet and outlet clearance, recirculation risks, cable bend radius, connector access, neighboring components, and service removal path. A clean fan model floating on a blank screen cannot reveal these system conflicts. Aerodynamic and thermal models can compare options and locate risk, but the result depends on geometry, boundary conditions, mesh, material data, and model assumptions. Record those assumptions. Use predictions to select prototype questions, then compare measured results with the model. Simulation supports a decision, it does not replace sample verification. These are real Longwell EC250 sample photographs. A useful prototype carries a drawing revision, bill of material revision, software or control revision where relevant, tooling state, and build deviations. It also has a stated purpose. Build a sample is vague. Verify fit, control response, and the specified operating points for revision is actionable. The prototype definition covers the impeller, motor, bracket, harness, connector, control settings, and any temporary tooling. Special characteristics and inspection status are marked before the build starts. If a substitute part or manual rework is used, record it. Otherwise, the test may pass while the intended design remains unverified. Fit testing checks more than bolt holes. Verify the mounting datums, inlet and outlet clearance, rotation direction, cable routing, connector and pinout, communication or speed control response, vibration path, and service access. The customer equipment or a representative fixture defines the interface. Any mismatch becomes a tracked item, not an informal note. Test the agreed operating points and record the configuration. Typical evidence can include airflow, pressure, input power, speed, and when required by the acceptance plan, acoustic and temperature data. Plot the points against the requirement and stated tolerance. A product curve copied from another configuration is not approval evidence for the sample. If the sample misses a requirement, define the gap, identify the likely cause, make one controlled change, issue a new revision, and retest the affected requirements. Keep the requirement, change reason, hardware identity, and test result linked. Random changes may improve one result while hiding which change actually worked or creating a new problem elsewhere. Sample approval should identify the requirement baseline, approved drawing in BOM, control or software revision, fit check result, performance data, remaining deviations, and authorized sign-off. Open deviations must have an owner and disposition. The exact deliverables depend on the project agreement. Approval is meaningful only when everyone knows exactly what configuration was accepted. The development project is not complete when one sample works. Production needs release drawings in BOM, approved sources, incoming checks, process and inspection plans, a reference sample or agreed limits, change notification, lot traceability, and triggers for revalidation. That is how a custom sample becomes a repeatable supply item. Actual timing depends on confirmed scope, tooling, test plan, and approval cycle.